Welcome to all. This is Dr. Vigneshwar Meka, Assistant Professor of Geography, Government Degree College for Women's, Autonomous, Begumpet, Hyderabad. Today, in this session, Chapter 3, the temperature distribution, we are going to cover the following points. They are introduction to temperature, heat and temperature, terms related to temperature, and difference between heat and temperature, ways of transfer of heat energy. Firstly, we will look into introduction to temperature. Temperature is a measure of hotness or coldness expressed in terms of any of several arbitrary scales and indicating the direction in which heat energy will spontaneously flow, that is from a hotter body to a colder body, that is higher temperature to lower temperature. The differential amount of sun energy received by various latitudinal zones on the earth is the primary reasons behind the occurrence of seasonal patterns of the weather and climate. Thus, understanding the patterns of distribution of temperature in different seasons is important for understanding various climatic features like wind system, pressure system, and precipitation. Now, let us see what are heat and temperature. The energy transferred from one body to another due to the temperature difference between them is called heat. The quantity by which you can compare how hot or cold a body is called temperature. Simply, the intensity of heat is called the temperature. In a CGS system, the unit of heat is calorie. It is equal to the quantity of heat required to rise the temperature of heat 1 gram of water through 1 degree Celsius. Degree Celsius, degree Fahrenheit, and kelvins are the units of measuring the temperature. And there are three types of the popular scales used to measure the temperature. They are Celsius scale, Fahrenheit scale, and Kelvin scale. So there are few terms to discuss as a part of the temperature. One, the Celsius scale. On the scale, ice point is 0 degrees Celsius and steam point is 100 degrees Celsius, and the distance between these two fixed points is divided into 100 equal parts. Each part corresponds to a difference to the temperature of 1 degree Celsius. The Kelvin scale. On the scale, ice point is 273 kelvins and steam point is 373 kelvins. The distance between these two fixed points is divided into 180 equal parts. Each part corresponds to a difference of temperature of 1 degree Kelvin. So the picture on the screen discloses you about the Celsius scale, Fahrenheit scale, and Kelvin scale. The Fahrenheit scale is founded by the Gabriel Daniel Fahrenheit, and it is named after him. On the scale, the ice point is minus 459.67 degrees Celsius and the steam point is 212 degrees Celsius. The third is the specific heat. The specific heat of a substance is the amount of heat which is required to raise the temperature of a unit mass of the substance by 1 degree Celsius. It is standard SI unit is calories per grams degree Celsius or joules per kilograms degree Celsius. The next is thermal capacity. The thermal capacity of a body is the amount of heat which is required to raise the temperature of a unit mass of the substance by 1 degree Celsius. Its SI unit is calories by grams degree Celsius or joules per kilogram degree Celsius. Melting point. The temperature at which a substance changes its state from solid to liquid is called its melting point. Then boiling point. The temperature at which a substance changes its state liquid to gaseous condition is called its boiling point. The SI unit of heat is joules. And lastly but not least, the calorie. The calorie is defined as the amount of heat required to raise the temperature of 1 gram of water by 1 degree Celsius. Now, we will look into the difference between the temperature and heat. The interaction of incoming solar radiation or insolation with atmosphere and the Earth's surface creates heat. This is measured in terms of temperature. While heat represents the molecular movement of particles comprising a substance, the term temperature is the measurement in degrees of how hot a thing is. So, heat is the energy which makes things or objects hot, while temperature measures intensity of heat. Heat and temperature are closely related to each other because gain or loss of heat is necessary to raise or lower the temperature. The Celsius scale is the internationally accepted scale for reporting air temperature. Fahrenheit scale and Kelvin scales are other scales used to measure the temperature, and these are internationally accepted. And the Fahrenheit scale is based on 30 degree Fahrenheit for the freezing point of water and 212 degree Fahrenheit for the boiling point of water, with the interval between the two being divided into 180 parts. On the Kelvin scale, 0 Kelvins represents absolute 0 degrees, that is minus 273 degrees Celsius, the temperature at which the molecules of a substance have their lowest possible energy. Heat is transmitted by the process of radiation, conduction, convection, and advection. And these processes are called the 4 processes of transfer of heat energy. Each of the 4 mechanisms of heat transfer has an important role in affecting weather changes. The process of heat energy transfer are 1. Radiation, 2. Conduction, 3. Convection, and 4. Advection. The figure on the screen discloses you about the methods of heat transfer or the base of heat energy transfer. Now, we will look into the radiation. Radiation is the process by which Solar energy reaches the Earth and Earth loses energy to outer space. When the source of heat transmits heat directly to an object through heat waves, it is known as radiation process. In this process, heat travels through empty space. The vast amount of heat energy coming to and leaving the earth is in the form of radiation. The following facts about radiation are worth noting. 1. All objects, whether hotter or colder, emit radiant energy continuously. 2. Hotter objects radiate more energy per unit area than colder objects. 3. Temperature of an object determines the wavelength of radiation. Temperature and wavelength are inversely related. Hotter the object, shorter is the length of the wave. 4. Insulation reaches the Earth's surface in short waves and it is radiated from the Earth in the long waves. We will be amused to know that the atmosphere is transparent to shorter waves and opaque to long waves, hence energy leaving the Earth's surface, that is terrestrial radiation, heats up the atmosphere more than the incoming solar radiation, that is insolation. And the second process of heat energy transfer is conduction. Heat transfer through conduction happens due to the molecular activity in a conducting medium. There is no actual movement of the medium itself. Generally, denser material like iron, water are good conductors, and lighter medium like air are bad conductors of the heat. When two objects of unequal temperature come in contact with each other, heat energy flow from the warmer object to the cooler object, and this process of heat transfer is known as conduction. The flow continues till temperature of both the objects becomes equal or the contact is unbroken. The conduction in the atmosphere occurs at zone of contact between the atmosphere and the Earth's surface. However, and this is a minor method of heat transfer in terms of warming the atmosphere, since it only affects the air very close to the Earth's surface, that is lower parts of the atmosphere. And third process of heat transfer heat energy transfer is convection. Convection is the transfer of heat energy by actual transfer of matter or substance from one place to another. For example, heat transfer by convection cells in a boiling pot of water, atmosphere, and oceans. Transfer of heat by movement of a mass or substance from one place to another, generally vertical, is called convection. The air of the lower layers of the atmosphere get heated either by the Earth's radiation or by convection. The heating of the air leads to its expansion, its density decreases, and it moves upwards. Continuous ascent of heated air creates vacuum in the lower layers of the atmosphere. As a consequence, cooler air comes down to fall the vacuum, leading to the convection process. The cyclic movement associated with the convectional process in the atmosphere transfer heat from the lower layer to the upper layer and heats up the atmosphere. The upper layers of the atmosphere are receiving temperature by the convection process. And fourth fast process of the heat energy transfer is advection. Winds carry the temperature of one place to another place. The temperature of a place will rise if it lies on the path of winds coming from warmer region. The temperature will fall if the place lies on the path of the winds blowing from cold regions. The process of advection, horizontal transport of heat by winds, is called as advection. I repeat, the process of horizontal transfer of heat energy by winds is called as advection. The figure on the screen discloses you the advection, heat advection, that is horizontal movement. And the advection is also called as the heat parallel movement. So far, we dealt with introduction to temperature, the terms of heat and temperature, and terms related to the temperature, difference between heat and temperature, and ways of transfer of heat energy, such as radiation, conduction, convection, and advection. Thank you. Thank you, Randall. Thank you very much.